Good morning. Today we are going to see one more technique on filters, particularly designing a digital filter wherein we'll use a transformation to convert analog filter into digital filter. That technique is bilinear transformation technique. Bilinear transformation technique uses trapezoidal rule of integration for conversion of continuous time transfer function into digital filter. It uses the substitution s is equal to 2 by t times of 1 minus z power minus 1 by 1 plus z power minus 1. Now we'll see how we came into this particular substitution, that is s has to be replaced by 2 by t times of 1 minus z power minus 1 by 1 plus z power minus 1. That means to say that in the final transfer function, which is in terms of s domain, you need to replace s by this. Okay, that is 2 by t times of 1 minus z power minus 1 by 1 plus z power minus 1. Sometimes they'll give the value of t. If the value of t is not given, assume it as 1 second. Or sometimes they'll give sampling frequency f, through which you can find sampling time, and you substitute that over here, and then finally make use of this substitution, and that means to say that replace s by the final quantity that what you'll obtain after you substitute for the value of t. Now let us see how we arrived at this. Let us consider a derivative which is given by t into y of t by dt, that is equal to x of t. Let me call that as equation number 1. So I'll apply Laplace transformation on both sides. Laplace transformation of d into y of t by dt is equal to s into y of s. Similarly, Laplace transformation of x of t is given by x into s, or x of s. I call this as equation number 2. Now I'll integrate equation number 1 with respect to t to find y of t within the limits n minus 1 of t to nt, where t is the sampling period and is given by this particular equation. See here, integral n minus 1 of t to nt d into y of t by dt with respect to dt is given by integral within the limits n minus 1 of t to nt x of t dt. Okay, call that as equation number 3. Now I'll apply integration. Now what is integral of d into y of t by dt with respect to dt? It is y of t. Limits are n minus 1 of t to nt. N minus 1 of t to nt. RHS I'll keep that as it is. Okay. Now I'm going to substitute the limits. So if you substitute the limits, you will get it like this. As I told, I'll keep RHS like that. Now I'll apply trapezoidal rule of integration for RHS. The integral on RHS of force can be approximated by trapezoidal rule like this. That is, integral x of t with respect to dt with the limits n minus 1 of t to nt is given by x of nt plus x of n minus 1 into t by t into t as per trapezoidal rule. Now what I'll do is I'll going to use this in equation number 4, that is substitute phi in 4. So if you substitute phi in 4, you'll get it like this. That is now y of n minus, so y of nt minus y of n minus 1 into t as usual, which is there in 4. I'll replace RHS by equation number 5. Okay, as a result you will get it like this: x of nt plus x of n minus 1 into t by 2. Since x of n is approximately equal to x of nt, I'll replace x of nt by x of n. Similarly, y of nt by y of n. As a result, you'll get this equation. See here, instead of n into t, I'll replace it by y of n. Here, I'll keep that as it is. Okay, here again, I'll replace that by this. I'll replace this by this, all multiplied by t. Now for this, I'm going to apply z transformation. What is z transformation of y of n? It is y of z. The transformation of y of n minus 1 is equal to z power minus 1 y of z. Similarly, z transformation of x of n is equal to x of z. X of n minus 1 is equal to z power minus 1 x of z whole divided by 2 whole multiplied by t. Now I'll take y of z as common here, or x of z as common in RHS. As a result, you will get it like this. Now x of z is given by 2 by t times of 1 minus z power minus 1 by 1 plus z power minus 1 into y of z. I call this as equation number 6. Now compare equation 2 with 6. Equation 2 is like this: x of s is equal to s into y of s. Now if you compare this with this, what you will get for now s, see here, this is in analog domain, this is in digital domain. Similarly, y of s analog domain, y of z digital domain. Here the term s in analog domain, after applying trapezoidal rule of integration, you will get it like this. Okay, that is s is equal to 2 by t times of 1 minus z power minus 1 by 1 plus z power minus 1. That's what we use in bilinear transformation technique. That is, we place s by 2 by t times of 1 minus z power minus 1 by 1 plus z power minus 1. Now after you apply this, that is after you put this substitution, obviously transfer function will be in terms of z domain. But after you convert a transfer function from analog domain to digital domain, even at digital domain, your filter should remain stable, right? We're going to check the same now. Let s is equal to sigma plus j omega be any analog pole. In digital domain, it is given by z is equal to r in t power j omega. Now what I'll do is substitute this in equation number 7, that is these two in equation number 7, so that you will get sigma plus j omega in LHS 2 by t times of z is given by r in t power j omega, r in t power j omega whole power minus 1. Now e power j theta is given by cos theta plus plus j sin theta. I'll use the same, I'll expand that. Okay, then I'll separate real part and imaginary part so that you'll get it like this. Now after that, what I'm going to do is I'll multiply conjugate of the denominator to this and then further simplify. You'll get it like this, which you call it as equation number 8. Now what I'm going to do is I'm going to equate real part as well as imaginary part of equation number 8. Real part here is sigma. Sigma is equal to this one, that is r square minus 1 by r square plus 1 plus 2r cos omega into 2 by t. Similarly, this omega, which is imaginary part, is given by 2r sin omega by r square plus 1 plus 2r cos omega. I call this as equation number 10. Now from this equation, we can draw or deduce the following conclusion. That is, when r is less than 1, obviously you will get sigma less than 0. As what is the meaning of it? Sigma less than 0 is nothing but left of poles, right? Where it has been mapped inside the circle. Similarly, second case, r is greater than 1. If r is greater than 1, obviously sigma will become more than 1. What is the meaning of r greater than 1? It is outside the circle. When you will get, when poles will be mapped outside the circle, when it is, or when poles are in RHS. Okay, so in general, the poles situated outside the circle or in RHS will leads to unstable system, isn't it? So we won't consider that. Similarly, when r is equal to 0, what will happen? Sorry, r is equal to 1, what will happen? Sigma will become 0, only you will get omega. In other words, you'll get only imaginary axis in S domain, right? That will be mapped on the circle with unit radius, which we generally call it as critically stable one. Okay, so now this is the substitution for r is equal to 1, sigma will become 0. So here you will get it like this. Okay, after you substitute, so this can be written like this. Now if you use sin 2 theta is given by 2 sin theta cos theta, 1 plus cos theta is equal to cos square theta by 2. Okay, so I'll use those substitution, I'll expand, simplify, finally I'll get it like this. Omega is equal to this much, or this omega, distal omega is given by this. Okay, where this is analog omega, this notation is time period, this notation is distal frequency. Okay, now it has been observed that when analog omega is equal to distal omega, distal filter will have same amplitude response as that of analog filter. Obviously it has to happen. But it has also been observed that at higher frequencies, when omega is equal to omega, response of the filter is as if it is nonlinear in nature, due to which distortion will be introduced both in digital design as well as analog design. This effect we call it as wrapping effect. Okay, I'll repeat once again. When analog omega is equal to distal omega, in other words analog frequency is equal to distal frequency, when frequencies are very high, the response of the filter is nonlinear and distortion is introduced both in digital design as well as analog design. This effect we call it as wrapping effect, and it needs to be overcome. Otherwise, if we don't overcome this, your filter will behave as if it is nonlinear. So in general, nonlinear systems are not stable. So we are not designing a unstable system. As a result, we need to overcome the nonlinearity. How? That can be overcome with the help of overcoming the wrapping effect. That can be achieved with the help of pre-wrapping. Okay. So how to do pre-wrapping? That will be the next question. Pre-wrapping can be done like this. That is omega p dash or omega p star. In some textbooks they'll use this. In some other textbook they'll use this. Is given by 2 by t times of tan of omega p by 2. That is distal omega p by 2, where distal omega p is given by analog omega p into t. Similarly, omega s dash, that is stop band frequency or pre-wrapped stop band frequency, is given by omega s dash or omega s star, that is equal to 2 by t times of tan of omega s by 2, where again distal omega s is equal to analog omega s into t. So after you pre-wrap, or this will become the first step in by BLT, that is bilinear transformation technique, that is we need to pre-wrap. Okay, from here onwards in designing, wherever you will find omega p and omega s, there it has to be replaced with help of omega p dash as well as omega s dash. That means to say that omega p will be replaced by omega p dash, omega s will be replaced by omega s dash in bilinear transformation technique, and this will be your first step in the design. Okay, in general, we used to find order of welder, right? Before that only you should do this step. That is, you need to pre-wrap the frequencies. Why? Because we need to overcome wrapping effect. Why we need to overcome wrapping effect? Because at higher frequencies, when analog omega is equal to digital omega, it has been observed that filter will behave as if it is nonlinear in nature. As a result, distortion will be introduced both in digital design as well as analog design, which is known as wrapping effect. It has to be overcome with help of pre-wrapping. Okay, hope you have understood this. Thank you.